Problem is from GATE 2017 mathematics paper, question number 3. The problem given is, let f of z equal to the function x square plus y square plus I times 2xy, and g of z equal to 2xy plus I times y square minus x square for z equal to x plus iy in C, that is z a complex number. Then in the complex plane C, the four given options are: option A, f is analytic and g is not analytic. Option B, f is not analytic and g is analytic. Option C, neither f nor g is analytic. Option D, both f and g are analytic. So by just looking at the options, it is asked, we can observe it is asked to check whether which function is analytic with either f or g in the whole of complex plane C. So the NPTEL reference to solve this problem is Module 2, Lecture 3 of Complex Analysis. The title of this lecture is Differentiation by Dr. P.A.S. Sri Krishna. He is from Department of Mathematics, IIT Guwahati. Even you can watch this reference video using this YouTube link. So now coming to the solution. So to check whether a function is analytic or not, the first of all, the necessary condition for an analytic function. So we have the necessary condition for a function f of z, which is written as u of x comma y, the real part, plus I times v of x comma y, to be analytic is, first of all, the real part and imaginary part has to satisfy the Cauchy-Riemann equations. CR equations has to be satisfied by f, u and v. And of course, this is just a necessary condition, which does not imply the function is analytic. So first of since so so for this, firstly, for the given functions f and g, we check whether the real part and imaginary part satisfy the Cauchy-Riemann equations or not. That is, for the functions, given functions f of z as x square plus y square plus 2y xy. So firstly, we'll see about the function f of z. So when we write this as real part plus I times imaginary part, then we have the real part as x square plus y square, and imaginary part is 2xy. So now we have to check for these two functions whether Cauchy-Riemann equations are satisfied or not. So Cauchy-Riemann equations are nothing but the derivatives, partial derivatives ux and uy, vx, vy has to satisfy some equations, which we'll see in a moment. So ux, from this real part, you have ux as 2x, and whereas vx as 2y, and uy equal to 2y, and vy equal to 2x. So now for Cauchy-Riemann equations, we have the Cauchy-Riemann equations are ux equal to vy and vx equal to minus uy. So these equations are called Cauchy-Riemann equations. So for the given function f of z, we have ux equal to vy, but uy is not equal to minus Vx. So, so Ux or U and V does not satisfy the Cauchy-Riemann equations or CR equations. So from this we can say f of z given as u plus iv, that is which we assume as x square plus y square plus 2ixy is not differentiable, and hence it is not analytic. So from the definition of analytic function, it is nothing but continuously differentiable. That is, the partial derivative has to be continuous and the derivative has to satisfy the CR equations. So first of all, here the function is not, sorry, the real part and imaginary parts are not satisfying the CR equation. So we cannot say the function is analytic. If it is analytic, then by the necessary condition, the real part and imaginary part has to be satisfy CR equations. So in the first case, in the case of f of z, we have it is not analytic. So coming to the function g of z given as 2xy, sorry, 2xy 2xy plus I times y square minus x square, and again writing this as u of x comma y plus I times v of x comma y. So we have u of x comma y as 2xy and v of x comma y equal to y square minus x square. Now for these two again functions, we have to check the Cauchy-Riemann equations. So for that we have to check ux and uy. Ux is given as, from the given function we get 2y and uy as 2x, and whereas vx is minus 2x and vy is 2y. So for these functions we have ux equal to vy and uy equal to minus vx. So u and v satisfies the Cauchy-Riemann equations, and hence f of z is differentiable. But it does not mean f of z is analytic whenever the function is differentiable. The sufficient condition is u and v has to satisfy u and v has to satisfy the continuous partial derivatives, and from the given conditions u and v, we can see ux, uy, vx and vy, these are nothing but the partial derivatives of the functions u and v, and from these functions we can easily see these are polynomials of linear of degree 1. Those are linear polynomials, and hence those functions are continuous. So we can say, and ux comma uy, vx and vy has have continuous partial derivatives, and hence f, sorry, g of z. Here also we are dealing about g of z. Therefore g of z is analytic, since from the definition of analytic function it is nothing but the real and imaginary part has to be whole continuous partial derivatives, and those has to satisfy the Cauchy-Riemann equations. Whereas in the case of the in the case of the function g of z, we have ux uy vx vy are holding continuous partial derivatives, and u and v are satisfying the Cauchy-Riemann equations, and hence we can say the function g of z is analytic. And so from the given options we can see it is given the option B. F is not analytic and G is analytic. That is what we derived. So answer is option B.